In Notes 6.5, we're going to be talking about properties of logarithmic functions. And we've talked about logs a little bit. They are inverses of exponentials. So when we're going through these properties, it's going to help you to remember what we did with exponents and then applying the inverse of that, so the opposite, to logs, okay? So really quick review, when we are in exponents, when we're multiplying exponents, something like x squared times x to the third would end up being x to the fifth because I end up adding the exponents together, right? Well, with logs, because they are the inverse of that, when we're actually adding the logs together, as long as they have the same base, that's what this b is for, then I'm actually going to just take the terms m and n and multiply them. So again, anytime I am adding logs, I'm actually going to be multiplying. Just like when you were adding or multiplying exponents, you ended up adding them. Okay, same thing, very similar with division and subtraction. So when we were dividing exponents, something like this, it would simplify to x to the third because you would take 5 minus 2, it gave you x to the third. Now with logs, anytime that we are subtracting log terms, we're going to take the terms and divide them by each other. So again, as long as they have that same base b, then we're going to take the term m. The first one goes in the numerator, the second one goes in the denominator. Now, here are some specific properties to just logs, and we can change the way that logs look, and this might help us solve for them. So here, anytime we have an exponent in our log term, I can actually take that and move it to the front to give me this instead. So the exponent attached to that m term can actually come to the front and become a coefficient. And then we have what's called log change of base. And we're going to use that when we can't really change the log to look like anything we want it to make the problem a little bit easier. So in this case, you take the log of m, put that in the numerator, and then you're going to take log again, but this time of the base b. Now, we work with bases of 10 in our numbers. So a little side note here, if there is no b, no base, we're going to assume it is 10. Okay. And this is what your calculator is going to automatically go to. If you don't put a base, it's just log base 10. And this will make a little bit more sense here in a moment. Okay, so we're going to do a little bit of practice here doing a change of base. All right. And change of base is just going to be following that formula. So I'm taking this log base 5 of 25. Now, the 25 would be like my m value here above. Let me do that in the same color so it's easier to see. So we're using log of 25, and that's going in my numerator. Log 25 over. And then in my denominator, it's going to be log of that base number. So log of 5. So you should be able to use your calculator here. Look for log on your calculator. If you're using like a TI-84, it's to the left of 7. And when you type that in, you get 2. All right. Let's do that one more time with log base 5 of 140. So again, we're going to take log of 140, and that's going to be my numerator. And then log of the little b, which is 5. And when I put that in the calculator, I get 3.07. Okay. So sometimes it'll be a nice number, sometimes it won't, and we'll talk about why that is here in a moment. All right, so that is how you use the change of base. Now we're going to be condensing and expanding expressions using these properties we just talked about. So remember, anytime you are adding log terms, you're actually going to be multiplying those terms together as long as they have the same base. If you are subtracting them, you're actually going to be dividing as long as they have the same base. And we are going to practice all of that right here. So these first two examples tell me to condense the expression. Condense means make it smaller, so make it one term instead of two terms. First thing you want to check for is, do they have the same base? They need to have the same base in order for you to make them one term. And then you just have to remember, okay, these are being added. So what was it that I did when logs are being added? If you relate it back to exponents, that might help you remember. And that means that you're actually multiplying the two terms together. In this case, that would be 2 and 32. So I'm going to put this together as log base 4. And I'm bringing the 2 and the 32 together. And I can multiply them because that is my product rule. This one right here at the very top. If they have the same base, I can take the terms and multiply them together. So 2 times 32 is 64. Okay, and we're going to leave it as log base 4 of 64. Eventually, we are going to show you what this means, but for now, we are just practicing making this one term. We're going to do that again with number 2. And number 2 is a good example of when there is no base, right? There is nothing there. There is an imaginary 10 always. Anytime there isn't a base specifically, you're going to assume it's 10, but it's not going to do anything for us right now. So they both have no base or base 10. Therefore, I can say, okay, that's going to be log, and then I'm taking these two terms and multiplying them together. So when I multiply 7 times x, that can just be written as simply log of 7x. And that would be me condensing these two problems into one term. All right, let's keep going. We have a few more examples here. So again, we're condensing. We're trying to make this one term if possible. Checking for that same base 3 in this case. And this time I'm subtracting, so I have to be careful that I'm paying attention. Am I adding? Am I subtracting? That's going to make a difference whether I'm multiplying or dividing. So in this case, I have the same base. That's going to stay the same for my one term. And then now that I am subtracting, that's going to mean I'm going to divide. So the first term is your numerator. So I'm going to put that at the top. The second term is going to be your denominator. Oh, sorry. Didn't mean to box everything, just the 5. Okay, and that is it. Right now, this is all we are asking you to do. Okay? Now, number 4 is a little bit longer. So first thing I'm checking, are they all the same base? That's going to make my life easier. Right now that we are just condensing, we're not going to give you different bases, okay? So making sure they're all the same base. Then I see that they're all being added. So just to make this easier on you, just take it 2 at a time, okay? I'm just going to focus on these 2. And because they are being added, I know that means I'm going to multiply the terms together. So really I have log base 3 of 4 times 2, right? I'm focusing on these terms right there. So that simplifies to log base 3 of 8. Then what I'm going to do is I'm going to bring this down. Now that I focus on the first 2, I can say, okay, now I'm going to continue on with the problem, log base 3 of 2, and do the same process. Because they have the same base, that's going to remain the same, log base 3. And now I am focusing on that 8 and 2, and because they are being added, that means I'm going to multiply. So 8 times 2 is 16. And that would be my condensed form. So just take it 2 at a time because soon here we're going to be mixing, adding and subtracting. So just 1 at a time. Moving along here for number 5. So number 5, has a new property that was in the front side of the notes, and that is this coefficient. Remember, this coefficient is technically an exponent to that term. So if I wanted to rewrite it, I could just make this go away and write it as log base 5 of x squared instead. That is what that coefficient is. It is the exponent. So really, what I have here is log base 5 of x squared minus log base 5 of x plus 4. That is a property for logs that you need to know. Continuing with my problem, I'm checking that they have the same base. They are being subtracted. Subtraction means divide. So I have log base 5 of x squared in the numerator. Just again, the first term goes in the numerator, the second term goes in the denominator. And you are done. That is it. That is how you condense this problem. Okay. A few more just condensing problems. I'm going to keep going here. Here we have another example of that exponent that can come up. So this 1/2 technically can become an exponent over here. All right. And thinking about properties of exponents, you know that power to the 1/2. So if I said x to the 1/2, that would become square root of x. Okay. So I'm going to rewrite it in those terms to make it easier for me. So this problem becomes log, no base. So remember that's an invisible 10, which is log 3. And then log of x to the 1/2, I almost did it there. We're going to write it as log square root of x. And then minus log 5. So take it 2 parts at a time. I'm going to focus on these two first because there's a lot going on. We have a plus and then a minus. So just one at a time here. Focusing on that plus, that means multiply. So this becomes log of 3 times the square root of x. Right, I'm just multiplying 3 times the square root of x. And then I'm going to bring this down now. Minus log of 5. So again, they have that same missing base or base 10, and I'm going to condense it into 1. This subtraction means that these terms are going to divide. So I have log. The first term is the numerator. The second term is the denominator. And I am done condensing. Number 7 is going to be that last problem for condensing, making this smaller. Now, these problems that have 2 negatives here. This problem, I personally don't like to deal with double fractions. So this is going to be a division and then another division. So think about it like a fraction divided by another fraction. That's what's going to end up happening here. So to avoid that, I like to think of this as factoring out a negative. So I'm going to factor out a negative and then leaving this next part of the problem inside. So let me finish writing here. Okay. What I did, the only thing I did here is I factored out a negative. If I were to distribute this back in, I would end up at my previous step. Okay? And once I go through this problem, you're going to see why I wanted to do this. But for now, if you understand that all I did from here down to that purple is factor out a negative and wrote it as one term there, then at the end, I will explain why that makes this problem easier, okay? So I'm actually going to focus. Actually, let's go back and fix this really quick. We know that anytime there's like a coefficient in front of the log, that can become an exponent. So I'm going to say that that's log base b of x to the 4th. And now I can start simplifying things. This technically also means that that is an exponent there. So that is also actually log base b of 6 squared plus log base b of y. And then everything else here is the same. Okay, let's start simplifying it. I'm actually going to focus on the parentheses right now because these are being added because I factored out the negative. And adding for me is just easier because that just means multiply the terms together. So because they have the same base, I can write it as one term, log base b. This first term is going to be 6 squared, which is 36, and then I'm multiplying it with the second term of y. Okay, so then if I bring back down the log base b, x to the fourth, now I have one problem to worry about, and that's that subtraction, which means I'm going to divide these terms together. So again, they have the same base. That's going to stay the same, log base b. Now this is my first term, so that's going to be my numerator, x to the fourth, and then my denominator is going to be the second term of 36y. Okay, and that would be my final answer. That exponent is the 4. Kind of covered it. Let me make sure I fix that. So the reason why at the beginning I factored out that negative is to make it easier, because multiplying terms is easier than dividing and then having to divide again. Most of us don't really like dividing by a fraction. So if I factor out the negative, then I can just multiply and then divide only once. Personal preference, but you might not care, so you can definitely do it by dividing twice. You would just focus on the first two terms and then bring down the second term like we did in that previous problem with the adding and subtracting. Now we're going to go backwards and expand the expressions this time. So instead of making it one term, I want to expand it and make it 2 or more terms, depending on how much is going on here. Okay? So again, keeping that same base, and then this one is just determining what is originally happening. Originally, these are being multiplied. So I know that if I wanted to split them up, that means that I need to add logs being added, right? So keeping the same base, log base 3, my first term in this case is 3 plus, and then that same log base 3, the second term here is x. And that's it. That's how you expand that expression. So going backwards, taking it one at a time. For number 2, again, taking it one at a time here. This is being divided, so I know I'm going to have some subtraction. Taking just the numerator is going to be my first term. So log base 7 of 2x. Then I'm going to subtract, now the denominator is going to be my second term, log base 7 of 5. Here's where you need to be careful. Is there anything else being multiplied or divided? If so, you need to split it up even more. This right here is technically 2 times x, right? And I know that the multiplying can be split up into addition, so I can go log base 7 of 2 plus log base 7 of x, and then keep the minus log base 7 of 5. So that would be fully expanded, making sure that there's only one term per log term. And then one more for this expanding practice. Taking it one at a time, I have log base 7 of all this. I'm going to split this up into just x squared times y for now. So this first term becomes log base 7 of x squared. And because these are being multiplied, I know I'm going to add log base 7 of y. If we can simplify that exponent, we don't have any exponent in the log terms unless we are condensing. So I'm going to bring that one down. Remember, that's a property. So I can say 2 log base 7 of x plus log base 7 of y. And that would be me expanding it. There's no other terms being multiplied or divided in my log term, and then there's no exponents left. All right, last little bit for these notes is to simplify these expressions. So before we simplify here, we need to remember something that we learned in the 6.3 notes, and that is the inverse property of logs. So if we have log of b to the x, these would cancel out, and I could simplify this to just be x, right? If I use numbers, something like log base 4 of 4 to the 5th, that would cancel out again, and I would just get 5. So these are important properties to remember when we are simplifying these expressions. The first thing we want to do is try to get this 27 to have the same base as the log that it's next to. So think about this as, is there a way to write 27 as a base of 3? Okay, so essentially, can I take 27 and write it as 3 to the something power? So let's see, 3 times 3 is 9, times 3 is 27. So 27 would be the same as 3 to the 3rd power, yeah? So if I bring this down, log base 3 of 3 to the 3rd, now what I have done is I have created this inverse property that we practiced with last time in the 6.3 notes. And this is going to allow me to come through and say, oh, log base 3 of the same base cancels out. So then the only thing left over here would be that 3. Okay, we are going to do this with all of these terms in hopes that we can simplify this problem a little bit. I'm going to keep the minus here for now, and I'm going to keep going with the next term. The next term I'm looking at is log no base, which remember means base 10 of 10 to the 5th. So if I draw in that invisible base, really what I have going on here is log base 10 of 10 to the 5th. Same thing happens, these cancel out, and the only thing I'm left with is that 5. So I'm going to bring that 5 down. Keep going here. I have the plus next, and then I'm focusing on this right here. I want to make sure, or try to at least, that when I rewrite 16, instead of writing 16, I am writing, is there any way I can write 16 with the base of 2? That way I can apply that again. So if I do 2 to the 4th, that gives me 16. Because I can rewrite it that way, these will cancel using that property from 6.3, and this would give me 4. So now I have 3 minus 5. 3 minus 5 is negative 2, plus 4 is 2, and that is how I simplify. So it's all about manipulating the way that this works or looks so that I'm able to use other properties of logs. So let's do that again one more time here for example 2. Take each term one at a time. Again, I'm trying to figure out if I can write 16 as a base of 4. That way I can use this property. So log base 4, and 16 is 4 squared. So I'm going to go ahead and change all of these first and then go back and cancel things out. This one, I'm going to say log base 5. And can 125 be written in as a base of 5? Well, 5 to the 3rd gives me 25, so that's good. Keep going. Minus log base 6. Can I write 216 as a base of 6? And that would be 6 to the 3rd. And then minus log, this is technically base 10 already, 10 to the 8th. Remember, when it's invisible, it's the 10. So I'm going to go through, and this is the fun part. We're going to cancel. That leaves me with the 2. Plus cancel. That leaves me with the 3. Minus cancel. That leaves me with the 3. Minus cancel. That leaves me with an 8. And then you can just use your calculator or do it in your head. 2 plus 3 is 5. Minus 3 is 2. Minus 8 is negative 6. And that would be your final answer. And that is the end of these notes.